All right, let's jump straight in. Welcome to today's Explainer, where we are literally putting a fatal Cambridge IGCSE computer science exam mistake on trial. Our mission today? To save your grades by figuring out exactly why so many students bleed marks on what really should be a straightforward data transmission question. We're going to treat this like a high-stakes courtroom case, and the evidence we're digging into today is absolutely crucial for your success.
We've got the smoking gun right here. This is an exact quote straight from the Cambridge Examiner report, and it shows us precisely where students go off the rails on a standard 6-mark network question. The scenario itself is pretty simple. A video conference is happening between delegates in the USA and Mauritius, and packet switching is being used to send the data. Students are asked to describe potential problems with the sound and video quality, but as the examiner clearly notes, they've failed to make the link. So let's find out why.
Section 1. The flawed evidence.
So, we are putting a totally typical student answer on the stand. Just take a look at this standard response. Video conferencing uses the internet to send video and sound to Mauritius. Now, I want you to pause and predict for a second. What critical technical mechanics is this generic answer completely ignoring? I mean, it mentions the internet, it mentions the destination, Mauritius, and it mentions the data type. So why on earth does this score a big fat 0 for technical explanation? Well, to answer that, we've got to look under the hood of the internet.
Section 2. How packet switching works. To build a winning case, we have to establish the facts. When you're on a video call to Mauritius, your computer doesn't just fire off one massive continuous file. Not at all. Instead, it relies on packet switching. Basically, this means breaking your video and audio data down into tiny, individual packets, routing them completely independently across the network, and then putting them all back together, reassembling them at the destination.
Think of it like the journey of our evidence. Step 1, the data gets chopped up into packets. Step 2, these packets are scattered, sent via entirely different routes across the internet, all based on whichever path happens to be the fastest at that exact millisecond. And then step 3, because they all took different paths, they must be very carefully reassembled in the correct sequence once they arrive. If you just write down the internet sends video, you are completely leaving out this complex 3-step mechanical journey. In just a second, I am going to reveal a hidden examiner clue that completely flips this answer from a 0 straight to full marks. But first, you need the framework that makes that clue super obvious. And to get there, we need to look at what actually happens when this technical journey goes wrong.
Section 3. Real-time video problems. Because those packets are traveling independently all the way from the US to Mauritius, they face totally different traffic conditions on the network. This means packets follow different routes, which means they take different amounts of time to actually arrive. Some packets might even hit a dead end and just become lost entirely. And hey, even the packets that do arrive safely still need to be put back into the correct sequence, which causes an inevitable time delay.
And this perfectly illustrates how those precise network delays lead directly to the absolute disasters we see on our screens. You see, the examiner doesn't just want the theory, they want the symptom. Because of the delays and lost packets we just talked about, you experience actual gaps in the data received. You get that awful freezing of images on the screen. The call drops out, or you get that incredibly frustrating pull-your-hair-out experience where the voice and the mouth are just completely out of sync.
So the absolutely crucial point for your exam is explicitly stating this cause and effect relationship on your paper. You can't just list the symptoms, and you can't just list the network theory. You must write an equation of logic. Packets taking different routes equals packets arriving at different times, which directly equals the visual errors of freezing and audio sync issues.
Section 4. Upgrading your answer.
To make sure you hit that exact length the examiner is looking for, you need a rock-solid framework. First, the concept. You state that video and audio are split into packets. Second, the evidence. You state that these packets take different routes and times to reach Mauritius. Third, the reasoning. You explain that reassembling these out-of-order packets causes a delay. And finally, the examiner wording. You explicitly link that delay to the freezing images and lip sync dropout. Doing this guarantees you hit every single requirement on the mark scheme.
Let's look at them side by side. Notice how vague and unconvincing the generic answer is. Video conferencing uses the internet to send video. It's just relying on the scenario nouns without actually explaining any of the science. But then look at the high-level answer. It flawlessly connects the underlying theory directly to the practical reality. Video data is split into packets, taking different routes, causing delay and image freezing. It's a tight, logical chain, no fluff.
Section 5. The final verdict.
All right, remember that hidden clue I teased earlier? Did you spot it in the logic?
The absolute golden key phrase you must include is real time. You have to explicitly state that the video conferencing is in real time. Why? Well, think about it. If you're just downloading a movie file, a 5-second packet delay doesn't really matter, right? The file just finishes downloading a tiny bit later. But because a video conference is live and in real time, that exact same packet delay completely ruins the call, causing all that freezing and dropping out. Giving that context is the key to unlocking the mark scheme.
To make sure you always have the airtight evidence you need for your assessments and to never miss a crucial examiner clue like this one again, make sure you subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations.
So you've completely mastered how packet switching causes delays in real-time video. But it kind of makes you wonder, doesn't it? Just how fragile is this global web we rely on? What happens when a packet doesn't just arrive late, but gets completely corrupted and destroyed along the way? Well, if you don't know how systems use checksums and parity checks to save our data from disappearing into the void, you're still at a massive risk in your Paper 1 exams. Click on our data transmission error explainer next to survive. I'll see you over there.